Hi, in this video I'm gonna show you guys how to solve question number 6 from exercise 14G. Okay, pause the video and go over the question now, please. Okay, welcome back. So in this question, this is a pretty good question because it allows us to practice on our calculus, right? Specifically the integration technique, and also it talks a little bit about area, right? And a little bit about the total region, and also the volume, right? So this is sort of like a question that has almost everything. So let's get started. Okay, so we have the graph on the right that has the equation of y is equal to cosine x plus sine 2x. And then we have region A and region B. Region A is above the x-axis, and then region B is below the x-axis. So region A should have, this is going to be positive, and this is going to be negative. Okay, just kind of keep that in mind. You can, you guys should be taking those mental notes as you guys are picking up the information from the question. Okay, so for part A, number 1, we can write this equation. This is A1. Y is equal to cosine x plus sine 2x. We need to write this as y is equal to cosine x multiplied by c plus d sine x. Okay, so we need to somehow change the way the equation looks to so that it's sort of like this factored form, right? So if you think about this, c multiplied cosine x gives us cosine x. So my c should be 1, correct? Does that make sense? Now, what's this? This d sine x. So it has something to do with this. So cosine x multiplied d sine x, I will get, I should get sine 2x, which is not as easy to see, right? This part, that's not as easy to see. However, there's this equation that says sine 2x is equal to 2 sine x cos x, right? So sine 2x is equal to 2 sine x cos x. So which means I can write this. This will be cosine x. If I factor that out of 1 plus, in fact, maybe I should slow down first. Cosine x plus 2 sine x cos x. So if I take out the cos x, I will have 1 plus 2 sine x. Right? So my c is equal to 1 and my d is equal to 2. Okay? That's my c, that's my A part 1. Now for A part 2, they want us to find the exact values of the x-intercept, because now this is in factored form, and x-intercept meaning y is equal to 0, right? Which means I'm just going to make this whole thing equals to 0. So it's either my cosine x is equal to 0, or 1 plus 2 sine x is equal to 0. Cosine x equals 0, that will be, so cosine x, if I look at my unit circle, that's my x coordinate. So it's either pi over 2 or 3 pi over 2, right? For the y plus 1 plus 2 sine x is equal to 0. So 2 sine x is equal to negative 1. Sine x is equal to negative half. Then x is equal to, so sine x, I'm looking at my y coordinate, which will be 3 pi over 2. My y coordinate is negative, so that will be 3 pi over 2. Is that right? Wait, let me check. Oops, that's not right. It's actually 11 pi over 6. This is 11 pi over 6. All right, so we have, let's see what we have here is, does it make sense or not? And there's another one which is 7 pi over 6. Okay, so on the graph that's given to us, we only have two x-intercepts, one over there and one over there, right? Now, which means out of these four values, only two will work. So if you guys take out a calculator and if you put this in, 3 pi over 2, that is 3 times 3.14 blah blah blah, which gives me 9 something. 9.3 times pi gives us 9.42 blah blah blah, right? And divided by 2, that gives us 4.7 blah blah blah. So which means 3 pi over 2 is actually somewhere here. Alright, so this angle is definitely outside of this graph shown to us. Now 11 pi and 7 pi over 6, one of them, the same thing, is also outside of this range. So let's see, 7 times pi gives us 21.99 something divided by 6. That gives us 3.66 something. So this point seems like 7 pi over 6. That point seems like pi over 2. What if 11 pi over 6? So 11 times pi divided by 2, that gives us 17 point something. So 17 point something is all the way on the right, right? So this is 17 point something. So maybe somewhere here. Again, that is outside of the graph shown to us. So this one is out. Okay, so we have just found the exact values of the x-intercept. So that's A part 2. Okay, I'm going to move to the next page. Alright, so we have found out that this is half pi, and that is the two x-intercepts are half pi and 7 pi over 6. For B1, where we are asked to find the area, what we have to do is since the area for A is going to be positive, the area for B is going to be, the number, the definite integral, is going to be positive for A and negative for B. Here they want us to find the area. We have to do them separately, right? So what we have to do is from 0 to half pi, and then the equation y is equal to cosine x plus, maybe not the y, sorry about that. This is cosine x plus sine 2x. Okay, you might be asking, why do I use the original expression to integrate? Why don't I use the factored expression? Well, it's simply because it's easier for me to, in this case, it is easier for me to do them, for me to integrate them separately, right? So this is going to be a positive value, and that will give me, how much is this? This is, so if I integrate cosine x, I get sine x. If I integrate sine 2x, I will get cosine 2x. The 2 is going to be a byproduct, so minus half. And then I'm going to substitute the values in there. So sine of half pi is equal to, okay, let me just do that. Sine of half pi minus half of cosine 2 times half pi. Right, this whole thing minus sine of 0 minus half of cosine 2 times 0. Right, and that gives me, so sine of half pi is 1. This is 1. Cosine of pi is equal to negative 1. This is negative 1. Cosine of pi is negative 1. Sine of 0 is 0. And then cosine of 0 is 1. So I will have 1 plus half minus 0 minus half. 0 minus half. But that will give me, so minus becomes positive. I will have 1 plus half, which is 2. Okay, that's my B1. The area on the area of A. This is only my area of A. right? This is the area of A, this one. Okay, now I need to find the area for B. So if I do the definite integral, it will be a negative, but since we're talking about area, we will have to convert that to positive. Okay. All right, same thing. Cosine x plus sine 2x dx. This is gonna be equal to. So everything is pretty much the same. It's only the substitution part that's different. And be careful with this. Just now I made a mistake. It should not be 0, right? It should be from half pi. Okay, be careful with that. This is half pi to 7 pi over 6. Now you just substitute. I'm gonna pause the video. I'll leave the substitution part to you guys, and then you guys. I hope you guys know how to do it. The substitution part, okay? It is negative 9 over 4. Okay. So, but since we know that area cannot be negative, so the area for B is gonna be 9 over 4. Okay, so B1 is the area of A, so we got that already. This is equal to 2. Now the total area of the shaded region, so I have 2 plus this 9 over 4. This is the area total, right? This is area total. This is area total. Would be 2 plus 9 over 4, which is 2 plus 9 over 4. 17 over 4. 17 over 4. This is 17 over 4. Okay? Now, part C. Find the volume of the solid formed when region A is rotated. So, in this case, this is easier because we don't really have to worry about if the area is above the x-axis or below the x-axis if we apply the formula carefully. So for C, I might have to squeeze a little bit. All right. Okay. So I will have to. If you guys remember the formula, it will be pi is equal to. So volume is equal to pi from 0 all the way up to 7. All the way up to. So they're only looking for region A, right? They're only looking for region A. So 0 to pi over 2, and then the equation squared, right? Equation squared dx. All right, and from here you can use your calculator, put that in your TI-84, and you should be getting value close to 9.12. All right, so that is the volume of this region. If we rotate that around the x-axis and make a 3D shape, this is the volume. All right. I hope you guys find this video helpful. Sorry about the time. It's a pretty long video, but this is a pretty long question. All right. Feel free to rewind, rewatch, and I'll see you guys in the next video. Bye bye.